Hello friends, so today I want to show you the point cloud, which is something that I really like, and it looks something like that. Yeah, it looks actually exactly like that. So we are going to build this with JavaScript. So we finally put some JavaScript to something nice. We do something not recursive, not fractal with JavaScript, which is cool, I guess. And so we create that thing just with JavaScript and some nice functions, so some BFG object. So what I have here is my vector class, which is the good old vector class that I told you in the previous tutorials, and I added a function to calculate the distance between this point, this vector, and another vector. So it's just the Euclidean distance between 2 points. So I will include this file into the description there, and then you can add this file. You should actually add this file into your Max folder. So you go into applications, and then you go into Max, which is right here. You go to show package contents, resources, C74, and you go to GS extensions, and I put this in Jitter. So you have here the vector class, so it gets automatically loaded every time you open Max, so you don't have to include anytime this file into your JavaScript file. Okay, so let's start. Let's actually begin by creating our BFG's function. So jit.BFG. We want 2 of them for the x and y coordinates of the points. So we're going to use this BFG to create coordinates for the points cloud, for the points turning the cloud. So this coordinate, the x and the y for this point, are decided by a noise function, which we take from the BFG object. Okay. So let's create this one, which is one plane, float 32. We actually need just one-dimensional noise, but since it doesn't work if we don't put at least a second dimension with the sides of 2. So we actually need just a dimension of an horizontal dimension, but we have to add a vertical dimension of 2 to make jit.BFG work. And then we are going to add the basis, which is noise gradient. Will be good for that. Okay, so let's create another one, exactly the same. So this is actually the x coordinate. Let me just make this yellow. This is the x coordinate, and this is the y coordinate, which is random, smoothed random generated coordinate. Okay, so what do we need? Let's encapsulate this. Let's encapsulate this and call these BFGs. Okay, so they are now lying here. Our encapsulated patch. Okay, for example, we need the noise to be signed. So let's create set at basis sig1. So we actually need the noise to go from -1 to 1. so we need the noise to be signed, and we just give it the basis this attribute at loading of the patch with a load bang. Okay. So what else should we need? We need actually a scale message, which will scale just the x dimension, and this is going to receive our scale from our mother patch. So let's create a receive object, receive scale. Let's also create a dim object, which is going to just change also the first dimension. We don't want to alter the y dimension. This is also going to receive the scale, which are actually just the dimensions. Okay, so let's receive also the bang to output this matrix. We're going to emit this bang. Let's actually make it a little cleaner. No, I hate that. Yes. Something like that. Okay. Yeah, I just don't like it, but I will stick with it. Okay. So let's create a jit pack object, because we actually need to pack these two matrices just in one matrices. Well, we don't need to do that, but it's just cleaner. I prefer to do this. And okay, we are actually done for the moment here. So now let's create the offset for this. Let's create the offset for these two. We actually need to take out the numbers from these functions generators. So we need an offset to offset into the x part of these into the x dimension of these functions, and to retrieve back the value that these functions generate. So we need an offset. Okay, let's create a counter. Counter will be our offset generator. This counter is going to receive a bang from our Q meter, and let's actually divide this for some big number like 200. We will going to change this if we want. And then, since we have two functions, we have to offset the second offset with just a random number, big one, enough big number to offset the the offset actually. Okay, so this is our first offset. We're just going to offset into the x dimension, and yeah, we need just another offset for the other BFG object. Let's create now. Let's actually encapsulate that. I'm going to call this offset. Why not? Okay. Let's actually do something like that. Create a couple of outlets so we can send these offsets to our functions. Let's also create an inlet to modify the speed of this offset, and so we need actually inlets also here. So an inlet here for this, and an inlet here for that. Kind of messy, yes. Of course, it's really messy. I wouldn't expect nothing less. Okay, so pam. Let's create that. This is actually the speed of our animation. So let's call this speed. Perfect. Okay. What else do we need? Well, now that we have all this stuff, we need to create a matrix which is going to be accessed inside our JavaScript file. So we strip out the second dimension since we don't need it, and we just you remember we packed these two one plane matrices from the BFG object, so we got a two-plane matrix here, and we strip the second dimension. Okay. So what we actually missed here is the weight attribute. Just going to weight our output, so it's actually like a multiplier for our output. So we're going to modify this with floating point number. This is actually the radius of our point cloud. Okay, so we got. Let's start working with JavaScript. So let's go this point cloud 1, because I just have another one. You can call this just point cloud. Of course, you can't find this file. Let's print the tape in the AutoWatch 1. Save this thing. Okay. And now let's open this in my new editor of choice, which is this Atom, which is really cool. I really just it's really a lot like Sublime, but I like most the colors. I like the colors more. Okay, so let's see. Now I just copy and paste this stuff here, and you can copy and paste it from previous tutorial, or just download the file, or just rewrite it all by stopping the video now and just copying all this stuff. But it's basically just what we need to render. So we have a window called cloud. It is floating, size 600. You can change this as you want. Anti-aliasing stuff. Windows position, well, this is just, I actually don't need that anymore. We have the depth buffer turned to 0 in order to have the blending enabled for all the objects in our context. The sync is turned to 0 in order to don't have it fixed to the refreshing rate of the screen, but you can also turn it on, it doesn't really matter. Then I have the render, I have the race color here, just white color for the background. Then I have a sketch object which has the blending enabled. It's not automatic, but this actually doesn't really matter. The color is black with a bit of alpha. And then I have the blend mode, which is alpha blend. So yeah, that's it. Let's see what else we need. So we need to access this matrix that we create. So let's create a new jitter matrix, which is this one. I'm just going to access this matrix here from inside JavaScript, and we can do this by creating a matrix and assigning them the same name of this matrix. So this is just the same matrix. Then I want to create dimension variable and give it size of 10, just like our BFGs, but I want to be able to modify this dimension, so I just use the declare attribute inside the JavaScript built-in function. It's written wrong. Oh, sorry, I already have a contest called cloud, so I will just call this cloud one, but you can still call it cloud just because I have another context called like that active at the moment. So declare attribute is just like a set function. So it allows me to change this variable from the outside just by creating a message with the name of this variable. So it's just like a set function. When I say set dim to the argument of this function, so Max has this built-in function called the declare attribute, which is quite cool. So we need also threshold for the point cloud. We will see what we need it for. Let's also declare this with a declare attribute. Oh, sorry, just want to be precise. Okay. And let's now create our function, our draw function, which is just a function that arrays our context with a render arrays function, just arrays the color buffer. Then we need a function called drawLines. Well, I call it like that. We still don't have this function, but this is where our point cloud algorithm takes life. Then we need to draw all this stuff, and then we need to draw swap. No, sorry, we need to actually draw swap all this stuff. We need to swap the buffers. After we rendered one, we swap with the other buffer that gets written, and then we have to reset all this stuff. We have to reset the sketch and erase all the commands that are stored in the reset q command place. Okay. So yeah, let's create also let's get out of JavaScript for a moment. Let's create the threshold variable threshold modifier for our threshold variable here, where it is. Yeah, here. Okay, just put it here. Yeah. And then we need let's create all the stuff we need outside of JavaScript. So we need this Q method, which is going to bang a draw message, which is going to render our to activate our draw function. Actually, I want to create a trigger because I want to have a little more control about how the flow of the patch is working. So I first want to send out the bang for the offset. Remember the offset here? It does an off bang. So this is the first thing to happen in our patch when it at a frame rate. Then I want to bang out the noise functions, and then I will draw. Yeah, that's okay. So this is actually the dimensions. So this is where the scale comes into play, because we scale the dimension of this, and we scale the scale of the function in order to let's actually see what we get from these BFG's functions. So bang bang bang. Okay, let's say we have dimension of them, a scale of them, and let's just divide this for something less, radius 2. Let's make it synced. Okay, so we have this two-dimensional. No, yeah, it's actually a two-dimensional noise gradient. And yeah, if we lower the scale, well, let's actually make the dimension a bit bigger. Okay. If we lower the scale, we get a smoother noise, which is not really useful for our purpose. So in order to have each point to have it's really diversified coordinates from the other points, we want to scale it at least at the dimension sides. So if we scale it less, it's still a bit smoothed. If we scale it at dimension sides, it's going to have exactly every point is going to have really diversified values. So yeah, that's it. Let's close this. Stop this for a moment. Oh, okay. Let's. Oh, this is my window. Hello. Can you get a little smaller? Okay, let's. We got almost everything we need. Let's actually create jit.gl mesh, not fill but GL mesh, to draw our points. So this is going to be cloud 1, and the color is going to be black. The draw mode is obviously going to be points. The point size, I like it to be 3, and blend enable, no, we don't need that. So this is going to be, take the points coordinates from this matrix right there, not zeta coordinates. This is going to be 2-dimensional animation, so we don't need third zeta coordinate. Okay, so let's actually get into the live of this tutorial and write the draw lines function. Okay. So since we actually need to iterate through every point, so since we actually need to iterate between every point in this point cloud, and we need to check if every point is close enough to every other point, to do that we basically need a double for loop, two nested for loops. So let's create the first for loop. Let's create the first for loop for variable e equal to 0, e less than dim. So this is where our dim value comes into play. E plus plus. Oh god, can I go plus plus? And then we need another one. So let's let's create first our coordinate 1 variable. So this is going to be an array, and this is going to access our get cell with is going to access our noise matrix with a get cell message. We are going to get every cell into this matrix and assign it to this variable c1 coordinate 1. Then we need another for loop. So for j equal, the var j actually needs to be equal to e. And why is that? Well, I will explain that in a second. J plus plus. So this is just an algorithm that I came up with, which so in order to, well, it's better probably if I just draw it. So let's go with sketch. No, it's called paint something, paintbrush. Okay. So we have this array here. Yeah, I should draw all single. Oh god, I'm so bad doing that. Mouse drawing. Cool. Okay. Well, this last one was pretty bad. Okay, so this is our array, and we need to check for every point in this array how close it is to all the other points. And we do this inside the second for loop. So we already have a first loop outside, and then we get inside this j loop, and we do like that. J it's equal to e, so the first time it's equal to 0. And we are going to check every other point. From the first one, we're going to check every other point. And then if we put j equal to 0, every time we are going to check again once, for example, once we are here with the e loop, so this is e equal to 0, this one, okay? 2, 3, 4, 5, 6. So this is e equal to 6. Okay, when we are here, we already checked all these points. But if we put j equal to 0, we are going to check this again and draw multiple lines on top of each other. Well, if we set e equal to j, we are actually going to just look for the next points, which we already didn't check for this specific point. And yeah, I think this is a solution to the repetition problem. So just kill this horrible drawing, and let's get back into our programming here. So let's create the C2 coordinates. This is going to be actually yeah, this is going to be also going to access the noise mat. Get cell j, of course, but I forgot here to I forgot here to create a location1 variable. This is a vector. Let's use our vector class. So we're going to access the x coordinate, and we're going to access the y coordinate, and z coordinate is just 0, because this is 2-dimensional. And let's go there. I create the log2. This is always a new vector. We are going to fill this vector with with our second coordinate value that we get for from the same matrix, but at a different coordinate. Well, for all the coordinates. Okay, so we have these two coordinates, and we're going to calculate the distance between these 2 points by using the distance function that I just added to the vector class. So we calculate the distance, the Euclidean distance between location 1 and location 2. Now we do this. If distance is less than our threshold and distance is different to 0, 0, 0, 0, 0, so they are not the same coordinate, because this way we are actually overlapping the coordinates at least once. Yeah, when j starts, it's actually going to check for the same coordinate between. Yeah, these are going to access the same cell, so we have to make sure that if it's the same cell, we don't draw a line. So we put this condition, and then we have to draw a like segment with our sketch object by simply doing that. log1 y 0, log2 x, log2 point y, and 0. Yeah, and that's basically it. We probably miss some. Well, we should be okay. I guess there's an error somewhere. Is there? Yeah. Line 30, it misses. What's your problem? Whoa. Yeah, I wrote bar, but it's actually a for loop. Okay, so should this really work now? I'm not really confident that it will work, but just oh yeah, I was right. Draw swap It's not a function, because it's not a function of my sketch, of course, it's a function of my render. What's in my mind? So let's see if now it, oh god, it's actually working. No. C2 is null, line 32. Why should this be null, for God's sake? Let me check here. What's going on? What's wrong here? C2 is null. Why? No. Something wrong. Something really wrong with this algorithm. So let me check. So guys, I figured it out. What it was actually, it took me a while, but I figured it out what it was. We weren't changing the dimension of this matrix with the theme attribute, so the array was out of scope, and yeah. So, but it's actually, it should be. I'm still not sure that it works. Let's see if it actually works. Please just work. It's not working. God, why it's not? That's incredible. It's still not working. Okay, so just give me another minute, please. Okay, guys, so I found it. I missed this my sketch draw command because it's not automatic. I set automatic to 0 because I'm so messy. Didn't remember that, and we need the my sketch draw command in order to draw the sketch object. So let's see. Now it actually works. And it's actually not working properly. Oh yeah. It's actually working. Sorry. This is so messy. This tutorial is so messy. So you can get up actually to at least 100. You can increase the radius here. You can get up easily to 100 points without having any performance issue. This algorithm is not really efficient, well, as efficient as it can get, I guess. But doing this in JavaScript apparently seems not to be so convenient for the performance. So the next time we are actually going to see how we can do this with Gen. So we are going to do the same, or at least really similar thing with Gen, and we are going to see which is better. Okay, so we made it through it. It was quite a long and hard way, but I hope it was somehow interesting and useful to see me fail so hard. See you to the next tutorial. Ciao guys.